All right, let's say that we actually have a problem that we're given a sample of 12 ballpoint pens. They have a mean diameter of 1.15 inches. The population standard deviation is known. So when the population standard deviation is known, you use the z-table. All right, when it's not known, you use the t. What is the 99% confidence interval of the diameter width of the population? So I just went into Excel, I typed in these numbers, the mean, the population standard deviation, the sample size, 12 ballpoint pens. Alpha, how did I get is 0.01 because it set a 99% confidence interval. So that, of course, is 0.99. You could either look up in a table to get this z value, or in Excel, you could do equal. And a lot of times what I have to do is if I don't remember, I just start typing norm, N-O-R-M, and then I see it's going to be this one right here. Returns the inverse of the standard normal cumulative, has a mean of 0 and a standard deviation of 1. And now it wants the probability. If you remember, you could pick this probability, but the problem is the 0.99. The problem is you have to add, remember when you read this, it's from the lower end, the lower tail, all the way up to this value. And that's the only problem, because if you just put that in, you're going to get the wrong answer. So what you have to do is you have to actually add this half, so 0.01, and then divided by 2. So that's very, very important that you understand that. In fact, that is so important. I'm going to see very quickly if I can find a graph. I know you can't see what I'm doing, but I just want to make sure you really, really, really understand why are we having to, here I found one, why are we having to do this? Because if you look this up in your table reads from all the way down here up to that 0.99, right? Well, I only want this middle region right here. So remember half of it, so what's the 0.005? That's the 0.01 cut in half. So half of it's down here, half of it's up there. So you could either look this value up in the book and then just absolute value it, right? Make it positive. Or you have to be careful that you're looking up really 0.995. And that's why I had to use the formula to do the 0.99 plus that half right there. And then that would give me, as you can see, that value. All right, so remember, how do you find the margin of error? The margin of error equals, okay, so this for the z, the critical value, times, and I'm going to put this in parentheses, the population standard deviation divided by the square root of the sample size, close and close. All right, so that's your margin of error. That's going to be my plus or minus, is my critical value times my standard deviation over the square root of my sample size. So then down here, I can do my lower limit is going to equal the mean minus my margin of error. And then next, this is going to equal the upper, the mean plus my margin of error. And what's kind of nice about doing this in Excel, well, let's just finish this first, is so this says with 99%, if I go out and I get 100 ballpoint pens, I would expect 99 of them to be within this interval. But what's kind of nice about this is what if you take another sample and your mean is a different value? Watch these values down here. So say 1.03. And then notice everything updates. And so that's the beauty of Excel, is putting formulas like this in here, because again, well, what if you wanted a different confidence? And so probably what would be best to do, even with my confidence, is put my confidence in, hard code that in, and then but my alpha, do 1 minus that value, and that way you have a formula, so when you change the confidence, it updates your alpha as well. So, I mean, Excel is wonderful to use if you really learn how to use it for the formulas.